All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we have, let's determine the forces acting on members A, B, C, member B, D, E, and member C, D of our frame shown here. So anytime we have a frame, our process should really be, first off, I come in and I look for, do I have two force members? I could do this step later. I tend to forget if I try to do it later though. So two force member is any member that has forces at only two locations. So if we just count off, where do I have locations, forces at? We can figure that out. So on A, B, C, I'd have things at A, at the roller, my internal connection at B, my 600-pound force, and at C. That's a 4-force member. Definitely not a 2-force member. B, D, E has things at B, 300 pounds, D, and E, also a 4-force member. Member C, D, though, has things only at C, only at D. We should be able to say this is a 2-force member. So I'm just going to put a big 2 on it to help me remember that. If it's a 2-force member, then when we actually come in and try to work with that, rather than putting in CX, CY, or DX and DY, I know in a 2-force member, the resultant of CX and CY and the resultant of DX and DY, for this member to be in equilibrium, those have to act in a straight line from one point where we have forces directly to the other one. So for this one, that would go straight from C to D, or else from D up to C. We just make a guess and the math will tell us if we were right. So we can put in just an FCD on this member rather than a handful of unknowns. It streamlines our work and makes it easier for us. But from there, we can come in and we want to start trying to find our support reactions, just like when we did a 2D rigid body equilibrium problem. That's really all we're doing here. The trick, though, is in frames, there's going to be times where we have too many unknowns to be able to find them all from the original overall free body diagram. That's okay. Find what we can. If we can't find any, we might just skip this step and come back to it later. But we can find all of them in this one. We have a roller at A, a pin at E. We can draw a free body diagram and analyze this. So let's start there. Our overall free body diagram. I should have an object that looks more or less like this. At A, I have a roller. From a roller, I should have one force perpendicular to the roller. So just going straight up, because the roller, or perpendicular to the ground, perpendicular to horizontal is vertical. We'll put an AY in. If I go over 2 feet from there, I'll get to pin B. Pin B is an internal one. I don't need to include that on my overall free body diagram. Just like when we found our support reactions in trusses, we didn't include the force in every single pin in the truss. It's the same idea here. This thing gets caught up internally. If we circled our free body diagram, we'd be cutting off the roller. Coming down around, we cut the pin. But I could close out that circle. I don't have to go through B, C, or D to make a full circle around my object, cutting it away from the wall and the ground. They shouldn't show up in this overall free body diagram. So we just leave that as a pin. Don't put anything there. And we'll go 5 more feet. 5 feet is going to get us to that 600-pound force. 600 pounds. So we can get that labeled. 600 pounds. 3 more feet gets us to the top right corner. 3 feet. And I don't need to do anything with that pin at C. The same reason I didn't do anything with that pin at B. It's an internalized one. Leave it off. If I drew a free body diagram of A, B, C, we would then need to come in and include those. But that's not what we're doing. My last distance, I can say 2 more feet gets us over to my pin at the very far right edge of this. So we can work with that one. That is going to be pin E. So I need an EY and an EX. I'm just guessing directions on them. Again, that was 2 feet, got us to the far right edge of this. From there, we can come in and try to sort out. We have one more force in here. From the bottom, if I go up 2 feet, I get to that 300-pound force. So we can put that in there. 300 pounds. 2 feet from the bottom, or 3 feet from the top. We'll label both of those. And that's our whole free body diagram. On this one, I have EX, EY, and AY, 3 unknowns. I have 3 equilibrium equations for rigid body equilibrium in 2D. I can find all of those. So let's start out. There's 2 unknowns in the Y. That's really just a bad place to start. Let's do some of the forces in the X. I'll get EX out. Even though this is an easy equation for us to set up and tackle, let's still make our full equation. It keeps us with good habits. sets the road for us to be successful. But summing the force in the x, I have 300 to the right, and I can subtract off EX because I assumed it went to the left. Minus EX equals 0. Or solving that for EX, we get our first answer. EX equals 300 pounds. I get a positive number for EX when I solve this equation, which just tells us I guessed the right direction in my free body diagram. So put an arrow in here. It's really going to the left, just like I assumed, getting that magnitude and direction. 300 is the magnitude, direction is to the left in there. For our support reactions, always get that magnitude and show the correct direction for everything. That takes care of EX. I still have two unknowns in the Y. Let's sum moments rather than making a system of equations. Let's sum moments here at E. We'll get rid of EX and EY. I can find AY. The other logical place here would be to sum moments at A. I get rid of AY and I can find EY. Either way works for us. If I'm going to come in and do moments at E. So with positive going counterclockwise, let's sum up my moments about point E. If I'm doing that, let's get that 600-pound force in there. It's going to cause a counterclockwise rotation about E, so put that in as positive. Force is 600. My distance is 2 plus 3. 2 plus 3 is 5. 600 times 5. AY would cause a clockwise rotation, so subtract it off, and my distance is 2 plus 3 plus 5 plus 2, 12. So minus, because it's clockwise, 12AY. And then finally, I need to count for this 300-pound force. It's also going to cause a clockwise rotation about E. So minus, my force is 300. And my distance is 2 feet. 300 times 2 equals 0. If I solve that for AY, my only unknown in here, I'm going to get that AY is 200 pounds. When I get that positive coming out from this equation, it means I guessed the right direction for AY here. I guessed it was going up, so put an arrow going up. Still getting positive. My answer is a positive with the correct direction. With that known, though, I have one unknown left. I can sum forces in the Y to get EY. Summing my forces in the Y direction. I have AY, 200, minus 600, my applied load, plus EY, my last Y force, is going to get us to 0. If I solve that one for EY, I get that EY is 400 pounds. EY is 400 pounds, and it's going up. I get a positive number from this equation, so my free body diagram, I guess the right direction. But that takes care of all of our overall, that global free body diagram. So to move forward with this, what we want to come in and do is say, well, I have my support reactions all calculated out. I need to come in and try to figure out what's going on at B and in member CD, at FCD for that, because we know it's a two-force member. It's going to be the same at either end of that. So I want to look at where do I have a member that I could explode and take a look at my individual piece and have ideally just 3 unknowns. Sometimes that's not possible. We'll have to bounce around between members a lot more. But ideally, what member has just 3 unknowns and has a known force on it? So for example, if I look at member ABC, I know A, we just found it. I know a 600-pound force. My unknowns at pin B, I'd have BX, BY, and FCD, 3 unknowns. Same thing with BDE, I'd have BX, BY. My 2-force member would get 1 unknown, FCD, 3 unknowns, and I would know 300 pounds, EX and EY. I can solve everything out. So let's go ahead and my horizontal line is going to be an easier thing to draw. So come over on the side and I'm going to make another free body diagram here. So we're working with our horizontal member. My support reactions, I don't change their direction around. So I have AY right here is 200 pounds going straight up for everything. 200 pounds. It's already known for us. I can then come in and say, well, what's my next piece? We're just going to start moving over to the left. So if I go over 2 feet, I get to point B. At B, this is now, I'm including these internal ones because I'm looking at my individual members. I disassembled it. B would now show up in my free body diagram. So I need to have a BY. I'll guess that it goes up. And a BX. I'll guess the BX goes to the right. BY and BX. 5 feet from that, 5 feet over, I get to my 600-pound force coming straight down. I'm 600 pounds. And then 3 more feet gets me to point C. So 3 feet is getting my edge of the beam. Rather than putting in CX and CY, again, this is a 2-force member. In a 2-force member, we can say our force goes in a straight line from one end to the other. So we can just guess the direction. I'm going to guess this goes straight up here. And I'd have a force in CD. And that would be my free body diagram I want to work with next. Again, 3 unknowns in here. I can find all of these. Let's sum forces in the X direction first. Get the really easy one out of the way. If I sum my forces, sum of my forces in the X direction, I have BX, and that's it for us. BX has to be equal to 0. If it's equal to 0, I don't care if you put down units. I don't care if you put down a direction on it. It's 0 in any direction with any unit system we want to convert it into. But I still have 2 unknowns in the Y direction. Let's do moments instead. So let's take positive as counterclockwise, and I'm going to sum up my moments about point B. So that's going to get me, FCD will cause a counterclockwise rotation, and it's 5 plus 3, 8 away. So 8 FCD. My 600 pounds will cause a clockwise rotation, so minus, my force is 600, and my distance is 5. And then finally, AY will cause a clockwise rotation as well. So minus, my force is 200, and my distance is 2. Minus 200 times 2 gets us all the way to 0. FCD is going to be my only unknown here, so I can say that the force in member CD is equal to, solving this out, I'm going to get 425 pounds. I get a positive number here. So on this free body diagram, I guessed the right direction. This is going up. But when we start getting with these internal connections, we want to go one step farther than that. We're going to have this equal and opposite thing. If I move to the next member, if I drew a free body diagram of CD, I'd have to change my direction around on this. So rather than just leaving it here, I need to say on a specific member. This was up when I was looking at ABC. On ABC. That last little piece is helping really clarify what member am I saying in here. Because if we get that wrong, we're getting sign errors is really what's coming out here. We might have the magnitude correct, but we have it bounced to the wrong piece. We could use that. Let's actually draw a really quick free body diagram of CD to kind of talk through that more. So if I drew, this is CD, C, and D. If I had FCD went up right here, that's what we just found, at point C, then when I move to the new member, it's going to go in the opposite direction. It would have to be coming straight down for FCD, which means down at D, I would have to show it going straight up, FCD. If I drew a free body diagram of BDE, that angled member, I'd have an equal and opposite thing again here. I'd show it going down on BDE. But as I move from one member to the next, we got to get that equal and opposite, the direction change. That's really why we're establishing on which member we're talking about. Because if it's going up here, then there is a member where it's going down. We just want to be clear with that. We have it clear. Let's get our last unknown, BY, figured out. So if I sum up my forces in the Y direction, we would get, I have 200 from AY. I have BY going up plus BY. I have 600 coming down minus 600. And I have FCD going up plus 425 is going to get us to 0. When I solve for BY, I'm going to get here that BY is a negative 25 pounds. That's when I guessed that it was going upwards. A negative up really is going downwards. We should always get our answer as a positive with the correct sign. So we'll take one more step. BY is, drop the negative, 25 pounds positive going down. And when we found that, we were working with member ABC. So on ABC, which is going to be our final answer for everything. Again, for our external supports or external connections, what's holding it up to the wall, to the ground, just get magnitude and direction. For the internal ones, what's holding members together, get magnitude, direction, and on which member as we go through that. But we'll go ahead and wrap up there. Hopefully this is a useful video for you. If it was, hit those like and subscribe buttons. Stick around. Let's get you an A with JJ.